Welcome back to your favorite intermediate algebra course. Good to see you guys. We are going to look at properties of rational exponents today. Our objectives is to use those properties of rational exponents and to simplify some expressions doing so. Let's take a look here at these properties I've listed and some examples. So if you remember the old product of powers property, we got these back a few sections back. So if you have a to the m times a to the n, you can go ahead and leave your base a and then add those m plus n, right? So we have 3 to the 1/2, 3 to the 3 halves. You got a product there. So you have 3 to the 1/2 plus 3 halves. In other words, 3 to the 4 halves, if you see it right there, right? Which is 3 squared or 9. Okay, the next one, a to the m to the n. So here's your power of a power property, which means you go ahead and you multiply that m and n. Okay, so I got 4 to the 3 halves squared. That means we're going to go ahead and multiply that 3 halves times that 2 over 1. So we get 6 over 2, which is 4 to the third, or 64. Okay, the next one is a power of a product. Okay, the power there's m, you got your product inside a and b. So you got to take that a to the m and b to the m. Okay, so if we have like 9 times 4 to the 1/2, you could go 9 to the half times 4 to the half, right? Or in other words, the square root of 9 times the square root of 4. 3 times 2, which is 6. Okay. Negative exponent property, a to the negative m equals 1 over a to the m. So you got 25 to the negative 1/2. That's a negative if you can't see that very well, which is, by definition, 1 over 25 to the 1/2. In other words, 1 over the square root of 25, which is 1 over 5. Okay, take your principal root on that. A to the m over a to the n. So this is, you got your quotient of a power here, okay, which is a to the m minus n. So for example, 6 to the 5 halves over 6 to the 1/2. You notice both of them have base 6 there to make this possible. And you can go ahead and you can subtract those. 6 to the 5 halves minus 1/2, which is 6 to the 4 halves, 6 squared, 36. Okay. Finally, we have the power of a quotient. Okay, you notice you have the m power on that, right? So a over b to the m is a to the m over b to the m. So for example, 8 over 27 to the 1/3, we got 8 to the 1/3, which is the third root of 8, right? Which we know is 2, because 2 times 2 times 2, you get 3 of those, gives you 8. And then that's over 27 to the 1/3. Well, we know the third root of 27 is 3, so that ends up being 2/3. Okay. Let's do some more here. Examples we'll run through. How about, let's go 7 to 2/3. 2/3, sorry, times 7 to the 1/2. Okay. 7 to 2/3 times 7 to the 1/2. So here's your product of powers. You say, hey, both of those are base 7. That means I got to add that 2/3 and the 1/2, right? Well, we got to get a common denominator here. So let's get a common denominator of 6. So this ends up being 7 to the 4, 6, plus 3, 6, or 7 to the 7/6. Okay, we leave it just like that. Let's do another one. How about 3 to the 1/4 times 5 to the 1/3. All of that is to the third. So this is power of a product here. Okay. So we go 3 to the 1/4 to the third. So that one's taken to the third. And so is this 5 to the 1/3 is also taken to the third. Well, you're going to multiply those two right there. Okay, and that's going to end up giving you whoops, sorry about that. That's going to end up giving you 3 to the 3/4 times 5 to the 3/3, or 5 to the 1. Okay, and you'll typically just leave it right there. 5 to the 1. Of course, you don't need to write it. Okay. About 10 to the 1/2 over 10 to the 1/4. You notice they're both base 10, right? So I can go ahead and subtract that. 10 to the 1/2, square root of a half. And then on the bottom, you got the 4th root of 10. So 1/2 minus 1/4. But you got to change that to 2/4 minus a fourth. So 10 to the 1/4, or the fourth root of 10. However you want to write that. Okay, I'll leave that in radical notation, which is what your textbook does quite a bit in this section. Or I'm sorry, exponential notation. Let's look at another one here. Let's go 12 to the 1/6 over 3 to the 1/6, all to the fourth. Now notice here they're both to the 1/6, aren't they? So you got 12 over 3 to the 1/6, and then all of that's taken to the fourth. And I know that 12 over 3 is 4, so I got 4 to the 1/6 now, which is all to the fourth. Okay, and then I go ahead and multiply that 1/6 times 4, which is 4/6. So 4 to the 4/6, or 4 to the 2/3. Okay, so that's using properties of rational exponents. Now let's do some with some radical notation here. Page here. Okay, so like the fifth root of 16 times the fifth root of 2. Well, they both have fifth root, so I can go ahead and put them underneath the same radical there, right? So fifth root of 32, so I'm looking for 5 of a kind here. So I say, well, let's see, 32 is 4 times 8, right? 4 is 2 and 2. 8 is 2, 2, 2. You see how you got 5 of a kind? So my answer is 2. Because the fifth root of 32 is 2. Okay? About third root of 108 over the third root of 4. Third root of 108 over the third root of 4. So, hey, they're both third root, aren't they? 108 over 4. And that would go, let's see, that's 27 times, right? Third root 27. Now I'm looking for 3 of a kind, right? So break that 27 into 9 and 3. 9 is 3 and 3. So 3 times 3 times 3 is 27, right? How many are we looking for? We're looking for 3 of those, aren't we? Third root, looking for 3 of a kind, right? And I have nothing left underneath, so that just ends up being 3. Okay? Let's go ahead and do some more radicals here. About fourth root of 48. Okay? So I want to break that up. So you know what? Let's see. 16 and 3 give me 48. I'm looking for 4 of a kind, right? 16 is how about 8 and 2? And I know 8 is 2, 2, 2. So there's 16, right? 2 times 2 times 2 times 2. And I still get that 3. I say, hey, I got 4 of a kind, don't I? So I got a 2 out front. And I'm still left with the fourth root of 3. Okay, so 2 times fourth root of 3 there.